Today we are going to learn about enhancing data insights with Seaborn strip plot. We will explore how to visualize individual data points using strip plots to identify trends and clusters in categorical data, gaining practical skills in creating and customizing strip plots for better data interpretation.
In this video, we'll delve into the world of strip plots, a powerful tool in the Seaborn library for data visualization. Strip plots offer a unique way to represent individual data points along categorical axes, providing a clear visual representation of data distribution and variability. Unlike other plots that aggregate data points, strip plots maintain the individuality of each data point, making them particularly effective for identifying patterns, trends, and outliers in categorical datasets. They are especially useful when dealing with small datasets, where maintaining data granularity is crucial. By the end of this video, you'll understand the contexts in which strip plots are most effective and how they stand out compared to similar visualization techniques like scatter plots and box plots. Before we dive into creating strip plots, it's essential to set up your environment correctly. We'll start by installing Seaborn and its dependencies. If you're using a Jitter notebook, which I highly recommend for its interactive features, you'll need to ensure that your Python environment is up to date. Begin by opening your terminal or command prompt and installing Seaborn using pip install Seaborn. Once installed, launch your Jitter notebook and import the necessary libraries. Import Seaborn as SNS and import matplotlib.pyplot as PLT. These imports will allow us to create and customize our strip plots with ease. Additionally, we'll configure some display options to enhance the readability of our plots. By the end of this setup, you'll have a fully functional environment ready for creating sophisticated strip plots.
Now that we have our environment ready, let's create our first strip plot using Seaborn. A strip plot is essentially a scatter plot where one axis is categorical. We use Seaborn's strip-a-lot function to generate these plots. Consider a dataset containing information about different species of flowers and their petal lengths. To visualize this, you can use the command sns.strip-a-lot x equals species, y equals petal underscore length, data equals dataset. This command plots each petal length according to its respective species, allowing us to see the distribution of petal lengths within each species category. By default, the points in a strip plot are stacked on top of one another, which can sometimes make the plot difficult to interpret. In subsequent sections, we'll explore how to improve readability and interpret these plots more effectively.
One of the main challenges when working with strip plots is the potential for overlapping data points, making it hard to interpret the plot accurately. This is where the jitter parameter comes in handy. Jitter adds random noise to the data points along the categorical axis, spreading them out horizontally. This makes it easier to see the distribution of individual data points. To apply jitter, simply add the parameter jitter equals true within the strip-a-lot function. You can also customize the amount of jitter by specifying a numerical value, such as jitter equals 0.2, to control the spread of points. By strategically using jitter, you enhance the plot's readability without distorting the underlying data trends. This technique is particularly useful when dealing with larger datasets where point overlap is more pronounced.
When dealing with multiple categories within a strip plot, the dodge parameter proves invaluable. The dodge parameter allows you to separate data points by a secondary categorical variable, specified using the hue argument. This is especially useful when you want to compare different groups within your dataset. For instance, if your dataset includes flower species and their petal lengths, as well as the region they were collected from, you can use sns.strip-a-lot x equals species, y equals petal underscore length, hue equals region, data equals dataset, dodge equals true. This command creates a strip plot where the data points are grouped by region, providing a clearer comparison between regions for each species. By using dodge, you maintain visual clarity and ensure that your strip plot remains informative and easy to interpret, even with complex datasets.
To enrich the insights gained from strip plots, combining them with other types of plots is a powerful strategy. A common combination is overlaying a strip plot on a box plot. This approach provides both individual data points and aggregate statistical summaries such as medians and quartiles. The command to achieve this is sns.boxplots x equals species, y equals petal underscore length, data equals dataset, color equals light gray, followed by sns.strip-a-lot x equals species, y equals petal underscore length, data equals dataset, color equals black. Similarly, you can layer a strip plot over a violin plot to reveal the distribution shape alongside individual data points. This dual approach offers a comprehensive view of the dataset, making it easier to detect patterns, outliers, and trends. By mastering these combinations, you enhance your ability to interpret complex datasets. Customization is key to making strip plots not only informative but also visually appealing. Seaborn offers a variety of options to change the aesthetics of your strip plots. You can customize the color palette using the palette parameter, choosing from predefined palettes or creating your own. Adjusting marker styles with the marker parameter allows you to change the shape of the data points, enhancing visual differentiation between categories. Additionally, adjusting the size of the plot can improve readability, especially for presentations. Modify the plot dimensions with plt.figure figsize equals width, height. Seaborn also supports different themes, which you can set using sns.set_style, allowing you to tailor the plot's appearance to your audience or publication standards. By mastering these aesthetic customizations, you'll create strip plots that are not only insightful but also captivating.
Strip plots are excellent tools for analyzing trends and patterns within your data. By visualizing individual data points along categorical axes, you can identify trends that might be obscured in aggregate plots. For example, if you have data on flower petal lengths across different species, a strip plot can help you spot which species have consistent petal lengths and which are more variable. Additionally, strip plots are effective for spotting data clusters and outliers, providing insights into data distribution. These patterns are crucial for data analysis, as they can inform hypotheses and guide further investigations. By interpreting these trends, you'll be able to draw meaningful conclusions from your data, enhancing your analytical skills and decision-making abilities.
While strip plots are powerful, they come with challenges, particularly when dealing with large datasets. One common issue is overlapping data points, which can obscure patterns. Utilizing jitter and dodge parameters, as discussed earlier, helps mitigate this challenge by spreading data points and separating categories. Another challenge is interpreting dense plots, where too many data points can overwhelm the viewer. In such cases, consider reducing the dataset size or using transparency to maintain clarity. Balancing aesthetics and information is crucial, as overly decorated plots can distract from the data. Finally, with large datasets, strip plots can become inefficient. In these cases, consider alternative visualizations or summarizing data before plotting. By addressing these challenges, you'll ensure that your strip plots remain effective and insightful. To demonstrate the practical application of strip plots, let's consider a real-world example. Suppose you're analyzing customer satisfaction scores across different regions for a retail chain. By visualizing this data with a strip plot, you can identify regions with consistently high or low scores, revealing areas for improvement. Start by plotting the data with sns.striplot x equals region, y equals satisfaction_score, data equals customer_data. Customize aesthetics and use jitter to enhance readability. As you interpret the results, consider the context. Are certain regions performing better due to specific initiatives? Integrate these insights into strategic decisions, such as resource allocation or targeted interventions. By applying strip plots to real datasets, you enhance your ability to make informed, data-driven decisions, ultimately improving organizational outcomes.
In conclusion, mastering Seaborn strip plots equips you with a versatile tool for visualizing and interpreting categorical data. We've explored the fundamentals of strip plots, from setting up the environment to creating and customizing plots for enhanced readability and insight. You've gained practical skills in using parameters like jitter and dodge to improve plot clarity, and in combining strip plots with other visualizations for richer insights. By recognizing trends, patterns, and outliers, you enhance your data interpretation capabilities. As you continue to practice and apply these techniques, you'll become proficient in creating powerful, informative visualizations that drive data-driven decision-making. Remember, the journey to mastering data visualization is ongoing, so keep exploring and experimenting with the tools Seaborn offers.